Alright guys, what is up? Mr. Rushka here, just going to record a little 5.5 and 5.6 lecture over the weekend. Alright, I'm going to start by redoing these last few problems right here, the how many triangles are possible problems from 5.5, because I didn't really think I discussed the ambiguous case very well, okay? Again, so these three problems give us what's called the ambiguous case, right? They give us what's called the ambiguous case, okay? That means there could be 0, 1, or 2 triangles possible. So, from the measurements they give us, okay? Okay, that's what ambiguous case means. And we know what we have in ambiguous case here, because if you draw this triangle, so I'm going to draw this triangle, I'm going to label it. If you draw it and label it, so here's big A, big B, big C, little b, little a, little c. If you draw that triangle, and you fill in your measurements, so let's put big B on there, 82 degrees, 17 and 15. All right, so if you fill those in, you'll see that you have ASS, right? They gave us angle side side. So that means we have the ambiguous case, which means there could be 0, 1, or 2 triangles possible from the measurements they gave us, okay? So here's how we figure out whether there are 0, 1, or 2, okay? So I think you guys know, here's what we're going to do. So we start the problem just like we do the other ones. So we're going to write down the law of sines. Okay, let's plug in what we have. So we have little c is 15. Little b is 17. Oh, whoops. Big B is 82. Okay, so let's start. Let's cross multiply this guy on the right here. So we have, let's do that to solve for C. So we get big C equals inverse sine of 15 sine 82 degrees over 17, okay? I'm going to do all this in degrees for you guys, okay? So putting this in our calculator, we find that we get what is that? 15 sine 82. Okay, use the bathroom? Yep, take care. Yep. Okay, so we get C equals 60.9 degrees, okay? So that's one answer we get here, okay? So C equals 60.9 degrees. All right? So good stuff. Okay, at this point, here's how we figure out whether there are any other triangles possible. So because when we put this measurement in our calculator, it did not give us an error message. We know there was no error message. No error message. So there's at least one possible. Okay. No error message, so there's at least one triangle possible, okay? So let's see, to see if there are 2 triangles possible, what we're going to do is we're going to take this 60.9 that we just found. We're going to subtract it from 180, okay? So it's going to equal 119.1, okay? All right? So let's think, okay? So we're going to take that 119.1 degrees, and we're going to write that up here as an alternate answer for big C. Okay. All right, let's think then, okay? Can we have, so let's pretend we picked this angle, okay? Can we have a triangle with an 82-degree angle and a 119.1 degree angle? Well, let's think about this. If we do 82 plus 119.1, that gives us 201.1 degrees, right? You cannot have a triangle whose angles sum to more than 180, so there can't be a 119.1 degree angle there. That means our alternate answer for C cannot be true. That can't be the case. So we only have one triangle possible, okay? Okay, so alternate answer doesn't work. So only one triangle possible. Right, and it doesn't work because angles can't sum to more than 180. Okay, good stuff. All right, let's try this other one right here, B. So again, let's do a little bit of review. We have the ambiguous case here. 28. Let's make this B. Right, we have the ambiguous case here, and this is big C and little c. We have the ambiguous case here because they gave us angle, side, side. So there could be 0, 1, or 2 triangles possible in this problem, okay? We don't know yet, so we got to do the law of sines. So sine big A over little a equals sine big B over little b, which equals sine big C over little c. Okay? Let's plug stuff in. 73 degrees. What's little a? 24. Okay, and then we have little b right here, which is 28. All right, so let's go ahead and solve for angle B real quick. Let's cross multiply, so we get 28 sine 73 degrees equals 24 sine B, or sine B equals 28 sine 73 degrees all over 24, or just B equals inverse sine of 28 sine 73 degrees all over 24. Okay. All right, so let's think about this. First, what I'm going to do to illustrate this example is I'm just going to crunch all the numbers into here in my calculator first. So I'm going to do 28 sine 73 divided by 24. So I get B equals inverse sine of about 1.11, okay? Try doing that in your calculator, okay? Inverse sine of 1.11. You should see error domain, quit go to. Value entered is not allowed in the function or command, okay? We can't put anything greater than 1 or less than -1 in an inverse sine or cosine, okay? So this gives us an error message, okay? So because there's an error message, there are 0 triangles possible. Okay, and then we're done. Done with the problem. Okay. It is impossible, it is metaphysically impossible to draw a triangle with a 73-degree angle and then two 28 and 24 length sides, okay? All right, so because there was an error message, there's 0 triangles possible, okay? Let's go down to this last case here. So let's draw, I'm actually going to end up drawing 2 triangles, and you'll see why there are 2 triangles possible. So I'm going to draw 2 of them. Okay, so I'm going to have A, big B, big C, which is 32 degrees. Little a is 18, little c is 10. Again, we have the ambiguous case because they gave us angle, side, side. Okay, that's how we know we have the ambiguous case. The ambiguous case means there can be 0, 1, or 2 triangles possible with these measurements, okay? So let's write down the law of sines. Sine 32 degrees over 10 equals what? Sine A over 18, which equals sine big B over little b. Okay. So let's start with the side we can solve by cross multiplying. So 10 sine big A equals 18 sine 32 degrees. Divide by 10. Where? I don't know. Looks like you upload it to. There's no submission. Email Mr. Meisnelder. I don't know. All right. So I'm going to hit both sides with the inverse sign. I get A equals inverse sine of 18 sine 32 degrees all over 10. Okay. Putting that in my calculator, I get about 72.5 degrees. So that's going to be one of my, so since that didn't give me an error message, I know at least, bathroom? Yeah. I know at least one triangle is possible. At least one. Okay. So there's a possible triangle where that big angle A equals 72.5 degrees, okay? All right, here's where the magic happens, okay? I'm going to go ahead. I'm going to copy this triangle. All right? There's an other alternate answer that we have to check to see if it works, okay? If it does work, we'll have 2 triangles possible. If it doesn't work, we'll just have 1 triangle possible, like we saw in part A, okay? So again, to find that, we take, our first answer, we subtract it from 180, right? All right, that gives us 107.5 degrees, okay? So let's, instead of putting 72.5, let's put 107.5 degrees there, okay? And then look at this, guys. If I add these 2 numbers together, the 2 angles that I have written down here, if I add those together, I get 139.5 degrees. Because that's less than 180, this angle measurement is possible, and I can fill in, I can fill in that third angle with my all 3 angles have to add up to 180 theorem, okay? All right, so that third angle is 40.5. Again, I just got that by adding up all my possible angles here. They have to all add up to 180. And then this triangle up here, it's going to be 72.5 plus 32, 180 minus that answer. In this triangle, that third angle is 75.5 degrees, okay? So basically what we have to do then, so I'll move this, and I'll write, I'll move my little note here, so 2 triangles possible. Now what I'm going to do here is I'm just going to use the law of sines for both of these. I'm going to solve for this last side, little b, on both these triangles, okay? So coming up here to this top triangle, I'll do this in pink. I have what? Sine 75.5 degrees all over little b. It's going to equal sine 32 degrees over 10. Right. So that's just from my law of sine 32 over 10. So that's just from my law of sines. Cross multiply b sine 32 degrees equals 10 sine 75.5 degrees. Divide both sides by sine 32 degrees. Okay, so I get b equals about 18.3 in this example. Okay, so in that triangle, possible triangle, B is equal to about 18.3. We've solved this entire triangle. We're done with that. Now we just have to find the little b for this other possible triangle where I used my second possible answer for big A of 107.5 degrees, which I found by doing 180 minus my first possible answer. Okay. All right. So let's do, again, we'll do sine 40 point. This time I'll do this in green. So we'll do sine 40.5 degrees, right? Big B here now is 40.5 degrees over little b. That equals sine 32 degrees over 10. So I'm using that sine of big C over little c. Cross multiply, you get 10 sine 40.5 degrees equals b sine 32 degrees. Divide both sides by sine 32 degrees. Get b equals about 12.3. So there you have it, okay? So we solved both triangles. These are our two, and there's basically two answers to this problem, okay? So again, little recap, right? We did everything like we've been doing to find our first possible answer for big A, right? That didn't give us an error message, so there's at least one triangle possible. I subtracted for my other possible answer for big A, I subtracted my first number here from 180. That gave me 107.5, and it works here because if I do 107.5 plus the angle that they already gave me in the problem, I get something that's less than 180. So I can fill in that third angle. Okay. All right. I'm going to stop right here for just to finish 5.5. I'm going to do this as 2 videos, and I'll do 5.6 as its own video. Okay. You guys take care.